Let's quickly look at the requirements of the application, what we are expected to do or what was done and how I implemented it. So again, shout out to DAS. This requirement was from them. And believe me, these are industrial standard on an application's workload should be on the Kubernetes cluster, making sure they are secure, automated, and follow the right principle. So what are the requirements? Quickly, you will build an end-to-end secure CI/CD pipeline that automatically scan, validate, and deploy a containerized application to Kubernetes cluster, while enforcing security best practices throughout the entire software delivery cycle. While using the low application as an application, but must be deployed in different namespace. So the various microservices must be deployed in namespace. And why is it important? It helps in what? In isolation, helps in resources management, helps in security posture, and many other things. So this is not a common practice in some Kubernetes cluster, but is the best practice. Each workload have their various what? Namespace. So we have the government API namespace, loan validator namespace, observability database namespace, and observability what? Namespace. So each application must have a different Argo CD application, the same. In order for us to manage each application with Argo CD properly, we have different Argo CD words application. And of course, what are the objectives? Implement a fully automated security audit deployment pipeline that demonstrates automated security scanning, CI/CD, GitOps-based deployment practices, policy enforcement, and compliance validation, least privilege access control. Very, very important. Now, what are the technical requirements? CI/CD pipeline implementation. You use a GitOps action workflow. The code security scanning implements SAST, which we do. We use Sonar Cloud and other SAST tool. Pipeline must fail at higher critical vulnerability as detected. So we do that. That container image security, build Docker image with security best practice. Many people just build Docker files anyhow. Oh no, we're going to see the best practices using building Docker file. Use minimal base images, run container as non-root user, implement multi-stage, scan images for what? Vulnerability is a tribute. Sign images using Cosign. Very important. Security, to make sure that your image is very intact as you left it. They will use Cosign to sign and also verify before deployment, so that if any image is tempered, you might just know and make sure that image does not go to what? Production. Many companies don't implement it, but standard enterprise 4500, this is what they do. Push image only if scan past defined threshold. Then we'll scan our manifest. Then let's quickly go to GitOps deployment using Argo CD. So we're going to use Argo CD, like we said, and we will make sure that each Argo CD application has automatic sync with self-healing. What it means that, yes, any changes happens, it does it immediately. If there's any changes either in the cluster or in the repo, it reflects immediately. We're going to implement sync waves for proper deployment order, and also add edge checks and sync hooks. So we're going to look at what this pre-sync and post-sync means in Kubernetes. Sync faces, going to look at them and those hooks. Then we're going to implement automated image tag update in manifest we're going to use shell script for that. Then the third part, we're going to look at Kubernetes security controls. So this is what is expected. How back implementation. Security is very important. How back helps in that security, role-based access control, least privileges to your pods, to your workload, so that they won't, go where they are not supposed to go. So that is what our back will do for us. I'm going to implement pod security, admission, and context for pods. Then we're going to make sure that those one we implemented is a false. It's one thing to say add this, but another thing to make sure that those things are added. So we are going to use Kavano for this purpose to make sure that all containers have resource limit block privilege, containers, efforts, image pool policy, and so many others. Then we are going to implement network policy to make sure that the required application is speaking to the required, the application it needs to speak to, not all applications speaking to each other. Then of course, this point is very important. We're going to use external secret operators so that, and we'll use AWS secret manager. This will ensure that what we can, our secret does not get to the GitOps, and it's stored with what on AWS. Then of course, we're going to attach Xborn, going to generate Xborn software bill of material. What this done is that it gets your image, bring out everything that is in the image, and this helps for you to visualize your image and see if there's any vulnerability, what it contains, and very, very important, industrial standard. That is what you see. So with all this implemented, as you are going to see in my next video, as we're going to be taking them one after the other,